Hey there folks, welcome to 1.3 distance and midpoints. At the time of recording, I am not completely sure how long distance is going to take, so this might be part 1 of 2. It might just be the whole video, not sure. But what distance is the length of the segment between those 2 points as endpoints. So I have point A and point B, and I draw my line. Okay, of course. Draw my line so that it's nice and straight there. And whatever length that segment is, that is the length of the distance. Sounds good. When you have this in normal life, you are going to be measuring it probably using a ruler, or you're going to be using other information that you know about the situation. However, in the coordinate plane, we can calculate distance. And this is the very important way that we need to know to calculate distance, okay? So here it is. So I'm going to say, okay, the distance from A to B is equal to, we're going to have square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. Cool. So I've got x1, y1, x2, y2. This is often a coordinate plane. Just plug in my values, evaluate, and I come out with a nice number. There is a pretty cool picture that your book has that maybe I'll draw in class. Talks about how you're basically you've got the line like this. You've got your line that you're measuring distance, and it's talking about the creation of the distance formula and how it is related to the triangle and the right triangle. So you have like your change in y and your change in x, which is similar to slope as well, but we're not measuring slope, we're measuring distance, and that's the formula. Now, another disclaimer. Hopefully I will show you guys that in class if we have time. Another disclaimer though is here's a little aside. Let me make it very aside. Honestly, so aside that I would rather you not write it. Do not write. Okay, so that's what it means. You can do the distance formula on a number line specifically, if that is something you need to do. You would just do the the distance from A to B is the absolute value of x squared, x2 minus x1. And it wouldn't matter which one was x2 and which one was x1. Now, here's the reason that I don't think you need to write that down. Picture this. It's our number line. We're about to do some very important distance formula on a number line, and then we say, oh my gosh, I do not remember what the formula is. I only remember in the coordinate plane. Well, you know what? you can just pretend that you're just along the x-axis. That's basically what you were doing anyway. So now you're at 0, and all that means is that everything that you plug in for y would be 0. So you're going to essentially have nothing here. It's just going to be x2 minus x1 squared, and then square root, which is the same kind of thing as taking the absolute value. It's going to give you only positive numbers, and there you've got it. So I only want to spend time with you on coordinate plane distance formula and midpoint formula because the number line is just not going to be used very frequently for you. And it also is literally inside of the coordinate plane formula. All right, so let's give this a try. Let's try using the distance formula because it looks a little intimidating. Here's my example. Let's find the distance between C, point C at -4, -6, and D at 5, -1. Okay, they have given us our points. I'm going to say, okay, this is going to be x1, and this is going to be y1, x2, y2. But if you had me last year, you hopefully remember that it doesn't matter which one you decide is 1 and which one you decide is 2. The thing that matters is that they are in the same order both times. So 1 minus 2 is fine. 2 minus 1 is fine. You just have to make sure the x and the y are both doing it. All right, so enough about that. CD is going to be equal to, I make my big square root sign. Let's go. So x2 is 5 minus x1, which is -4. Okay. And parenthesis squared plus parenthesis y2, which is -1, minus -6, okay, squared. And that's my first step. There's pretty clearly some simplifying that needs to happen there. So that turns it into, actually, I'm going to rewrite that as a new line. Just because I don't want to confuse you guys, it has to be subtraction here. And last year it was a challenge for some people to remember that. So we're going to say, okay, that's the same thing as 5 plus 4 squared plus -1 plus 6 squared. Make sure that square root is over everything that it is supposed to be over. Don't have anything sticking out the end. Okay, now I need to add things up inside of the parentheses. So CD equals the square root of 5 plus 4 is 9 squared plus -1 plus 6 is 5 squared. Cool. Next, I'm going to simplify those exponents there. I have the square root of 81 plus 25 then. So CD is equal to 106. And we're going to leave it. If you actually need to know this distance for more than a math problem, you might be interested to know that it is about 10.3 units. But we don't need to know that. So all that matters to me is that this is simplified in its simplified radical form, which it is, and then I can just leave it as the square root of 106 and move on to my next problem. Okay, let me do one more. No, let's move on to midpoint. We'll do a lot of distance and midpoint formula practice when we get back together. Okay, so midpoint. We talked about what distance is. Midpoint is a new thing, so we have to just define that specifically. So the midpoint of a segment so we have the distance between 2 points, and the midpoint of a segment is the point halfway between the endpoints of the segment. So let's say that we have, okay, well, they started out again with a number line in your book, so they do have that. I'm going to once again use the coordinate plane midpoint formula to teach you, because once again, it's just the catch-all. It has everything in it. So the midpoint formula, the way that I'm going to figure out if I have a segment like this, where is the exact center? Where is my exact center? Here's A, here's B, and I'm trying to find midpoint, M. What you are going to use is this. The midpoint is going to be x1 plus x2 over 2, then y1 plus y2 over 2. Now, there's no equal sign here, because what this gives us is a point. At the end, we would end up with an xy coordinate, which is the literal location of the midpoint. So it's kind of weird because these pieces right here are just our notation for an ordered pair. And you might feel like these are a little familiar. What those are is taking the average of your x value and the average of your y value. So we're basically just taking the average of each individual thing, but we're putting it inside of the ordered pair parentheses so that it's, I guess, super quick and easy when we finish calculating it. Okay? Again, pretty cool picture that I should draw for you in the book. So remind me if you want to see cool pictures. But I'm going to give you an example. Oh, this is going to be a long video. I feel bad. Forgot about Oh no. Okay. No, I'll end it after this. Here's your example. Finding a midpoint in the coordinate plane. I'm going to be looking for x1 plus x2 over 2. Okay, so the midpoint, they say it as m equals. I don't really like that. It's more like xm, x, or ym, because it's a point. So x1 plus x2 over 2, and y1 plus y2 over 2. Let's find the midpoint of the segment with endpoints S and T. Okay. Once again, we're going to decide which one is point 1 and point 2. It doesn't matter as long as you keep them consistent, but even that in this doesn't particularly matter because you have addition on both of them. So you're going to find that xm, ym by just plugging in. You have -6 plus 1 over 2 and 3 plus 0 over 2. Just going to do the simplifying of this here, and I get -5 over 2 and 3 over 2. Which, again, if you're actually trying to measure this out, or maybe even plot this point on a coordinate plane, you might want to say, well, that is equivalent to -2.5 and +1.5. But if you are just answering a question on an assessment, don't worry about it. Just make sure it's a simplified improper fraction. Okay? Alright, I know I haven't been giving you guys try problems. We will do lots of them in class, okay? This is going to be the stopping point for this video. There's a couple other things that I need to show you, a couple more examples. So there will be a part 2. I'm sorry.